Let me get rid of this problem, and then I will do the quiz problem for you. Okay. Marker. Let's see if this one works. So you said it was natural log of 1 plus x, and approximate the integral of 1 plus 2x dx from 0 to 1/2. Okay. Does anybody have this summation handy? Don't have that one memorized. Negative 1 to the n plus 1 x to the n over n. Is that right? Looks like this. Oops. Is that what you got there? Starts at 1. Okay. We all good now? All right, good. So if we want to approximate this guy, we can write out the first 5 terms of this. So plug in n equal 1. So negative 1 to the 2, that's positive. X to the 1 over 1, or just x. Then when we plug in n equal 2, this becomes 3 up here. So it's a negative x squared over 2. Then plug in 4. Plug in 3, which will make this 4, which is positive x cubed over 3, minus, and we can see the pattern now. So 1, 2, 3, 4, 5 terms. Now that's natural log of 1 plus x. If we want the natural log of 1 plus 2x, well, everywhere we see an x, we're just going to plug in 2x. So 2x minus 4x squared over 2 plus 8x cubed over 3 minus 16x to the 4th over 4 plus 32x to the 5th over 5. And then some of these reduce. So 2x minus 2x squared plus 8 over 3x cubed, 4x to the 4th, and 32 over 5x to the 5th. So those are the first 5 terms that represent this series. Now we need to integrate all of that. Let me use a different marker here. So I need the integral of this whole function that we've created. 0 to 1/2 dx. Let's see if we have any questions. No, you can put the 2x directly in there, and then you should get the same terms. It said 6 terms. Is that what you're trying to tell me? The first 6 terms? So picky. So what is 64 x to 6 over 6 and that reduces to 32/3. So we'd have that if you want to go 6 terms. All right. So integrate. So this is going to become x squared 2/3 x cubed. That would become x to the 4th. 8 divided by 4 is going to be 2. This is going to be 4/5 x to the 5th. This one's going to be 16/15 x to the 6th. And then I guess that'll be 32 over 21 x to the 7th. Everything's got an x, so we plug in 0, it all goes away. We just got to plug in half everywhere. So let's calculate that. It's taking forever to punch into the calculator. Okay, hopefully I did that all right. I got 0.188 something. Let's see what happens if I do the original with the FNINT, which is a good way to check yourself. You get 0.193 if I do that. So not terrible. So that's the actual That's the approximation. Yeah, looks good, guys. So that'll be very close to one of your test questions, right? It's going to say, here's an integral, here's a sum, find the first 5 terms of the sum, find the first 5 terms of this guy, the thing you need, plug it in, integrate, and give you an answer. Yes, the summation is on the test. So yes, I plugged 2x in everywhere, and you say, how did I get 4, 8, and 16? Because I plugged in 2x for x, it was squared. So 2x squared is 4x squared. Basically, the x becomes x cubed still, x to the fourth, but you're also doing the same operation to 2, right? So 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, so on. Sorry, my nose seems to be running a little this morning. Darn it. Okay. Anything else here? Yep, no problem. Alright, so then somebody asked me to do 3a, so let me do that. For each power series, find the interval of convergence. So I actually did 3a yesterday, so that's already up. Would you like me to do maybe 3c instead, or did you really want to see 3a? Alright, so let's try C then. Alright. So we start with the sum from 1 to infinity. And -1 to the n. It's like x minus 1 to the n. And down here we have n plus 1 squared. Yes, the other 3a I recorded yesterday during class. That's why I said it's already up, meaning it was on the video from yesterday. Alright. So the process is, first you want to take ratio or root test. And ratio is usually the one you're going to use. So the ratio test here, we take limit, n approaches infinity, absolute value, and everywhere we have an n, we make it n plus 1. So this will just become n plus 2 squared. Then we multiply by the reciprocal of the original. Close this up, and this has to be less than 1. So the negative 1 to the n's, or n plus 1, if I take the absolute value, they disappear. Or if you really want, you could say, get rid of that one, get rid of the n. You still have negative 1, but when you take the absolute value again, that disappears. I'm going to put these two squared terms together, and then I've got this x minus 1, which will cancel with that one and leave me just the x minus 1 to the first power. That cannot come out of the absolute value, but it can come out in front of the limit. So I have x minus 1 absolute value. That negative 1's already disappeared. And I still have the limit as n approaches infinity of n plus 1 over, and I'm just going to write it all together, n plus 2 quantity squared. Right, they're both squared, so I can put them both together. Then if I want to do the limit, well, then I would divide each one of these terms by n. Again, still all less than 1. So 1 plus 1 over n, 1 plus 2 over n. When I take the limit, anything that's 1 over n, or 2 over n, anything like that, goes to 0, so I'm just left with 1. So this whole thing just becomes 1. And now I've got absolute value of x minus 1 less than 1. That's going to give me my interval. If I have the absolute value less than 1, then negative 1 is less than the inside, and that's less than 1. So in order to solve this, I just need to add 1 everywhere. So that becomes 0 less than x less than 2. So that is my interval of convergence. But I'm not done because I have to see if these are equal. That's where the left and right endpoints come in. And what we do with those is we take one of these numbers, so the left endpoint, and we plug it back into the original. So I'll just say left. I have the sum, 1 to infinity, negative 1 to the n. Now if I plug 0 in there, 0 minus 1, this just becomes minus 1 to the n all over n plus 1 squared. These are both power n, so we could put them together. So negative 1 to the n times negative 1 to the n, that's just going to be 1 to the n. Or 1. So once we've simplified the series, the question is then, what kind of series is it? And therefore, how do I test it? So as much as I would like it to be, it's not quite a p-series. So question is, what test do we use? Any suggestions? Remember, for it to be a p-series, it would have to be 1 over n squared, but this is n plus 1 all squared. I'm thinking maybe a comparison test or a limit comparison. Right, if we were to square this all out, that'd be n squared plus 2n plus 1, which means the leading term is n squared. So we could compare it to 1 over n squared. That is a p-series. And p equals 2, which is greater than 1. So that converges. So if we do the limit comparison, right, limit n approaches infinity, then I want an over bn. Then I get n over n plus 1 all squared, divide through by n. And then all comes out as 1. So what are the rules of limit comparison tests? Anybody remember? So I would say it would be paramount to create a little note card for this one. So limit comparison says as long as you get a constant that's real and greater than 0, they both do the same thing. Oh, that's a constant that's real and greater than 0. So this converges. And if the left endpoint converges, you include it. So then we need to do the right endpoint. So I'm plugging 2 into this. So I would get sum n equal 1 to infinity. Negative 1 to the n. We plug 2 in there, we get 1 to the n all over n plus 1 squared. 1 to the n is 1. That basically just goes away. That's an alternating series. So we would need to prove that it's decreasing. So a plot of oops, I think I just had it in there. 1 over n plus 1 squared in the first quadrant is decreasing. So the graph looks something like this. So these are the parts that we don't need because they don't apply to the sum, but that's the function, just so we can distinguish it from other functions. The solid part is what's really the important part. So it is decreasing. The other criterion is that the limit as n approaches infinity of the absolute value of this goes to 0 when it does. So also included. So at the very end of the problem, you should write your answer as 0, 2, like that. Alright, so any questions about that guy? So again, the steps are uh, do ratio or root test to start, solve that all the way down until you get some inequalities, right, for x. Then test your left endpoint using whatever method is required. Test the right endpoint. So let me just make one more disclaimer because I see this all the time and it drives me nuts. Notice that both tests I use there just so happen to need the limit as n approached infinity. The thing that drives me insane is that people will test the left endpoint by just taking the limit as n goes to infinity, and the same thing for the right. That is not how it's done. You've got to plug in the endpoint, take the series that you now have, and decide what is the best way to test that series. So it all depends on what that series is. When can you do a limit test? So you're talking about the test for divergence, I assume? You can certainly try that, yes, but that will only tell you if it diverges. And if it doesn't, then you've got to do another test anyway. So in some cases it's useful, and in others it's not. So Jimmy, I see you asking about 6. So yesterday I was discussing that 6 and 7, they ask you to use to prove that it converges, then determine how many terms you need to approximate the series. That's that error integral. And if you were listening to when I was going over the problems for the exam, I did not mention anything like that. So no, I will not do number 6 because it will just be a waste of our time. Unless, of course, you just really want to know the answer. If that's the case, then we can do it outside of class. Alright, so before we do anything else, let's go and look at the review sheet and do, like I said, where I wanted to ask you guys what kind of tests you would use. So I need to put up a, let's see, I think it's a window capture, no, display capture. I always love when it does that. Alright, can everybody see the exam? Or the review, I mean? Just give me a second, I gotta open up the app on my phone so I can see your responses while I'm looking at this. So the problem is that when I open up the Studio, it does that as a screen. Yeah, I don't know why it does just a portion, and I can't scroll over either. Maybe if I zoom in and then scroll over. Actually, it won't even let me scroll now. Yeah, I'm not sure. See if I can see what you're looking at here. Darn it, why is it like that? All right, hold on just 1 second. All right, so for E, what would you choose? Not sure if my chat's updating. I don't see any responses. Let me check the page. Nope. Can you guys still hear me? Okay. All right, so let's try this again. Problem E here, 2E. What kind of test would you use to solve that? Absolutely, you could simplify that to just the sum of n. So that one, guys, is a P series. You could rewrite that as 1 over n to the negative 1. All right, let's try another one. What about, how about M? M is in mom. Okay, so that is an alternating series, but because of that n factorial, I think I would prefer to use the ratio test. Remember, the ratio test is always good to use when we see factorials. So m and n there look like they're ratio tests. All right. What about h? Okay, any other guesses? So hopefully you're seeing why this is a good exercise to just look at them and try to figure out what you would use. All right, you're going to have, I think, 4 or 5 problems. I think it's 5. Where you're going to be asked to just choose a test and use it. So that one, I think ratio would be a little difficult because you'd have to do natural log of n plus 1 over natural log of n. That one, I think the best course of action is an integral test. Right, because you've got natural log of n and its derivative 1 over n. So integral test for that one. What about A? So I think you guys are jumping the gun a little bit on the root test there. I agree everything is to the power n, but notice you've got a sum. Can't really break up the sum when stuff's to the power n. So yeah, if you break that into 2 sums, right, 2 over 6 all to the n plus 4 over 6 all to the n. Those are both geometric series. Let's see. What about P, as in Paul? If you break up part A, then if one of them converges, then the other must also converge. However, if one diverges, then you're done. The whole thing diverges. So it only works one way. Would that one be root? So that was P. Yeah, I would use the root test on that one. Yep, good, good. What else do we got here? What about J? So good. Yeah, I think I would use comparison test for that one as well. So when you guys go do this again for your review, all of these the solutions are at the end, and they all tell you what test and whether it converges or diverges. All right. So after that exercise, are there any other problems you would like me to do? So here's those right here. It tells you the divergent by test of divergence, that sort of thing. 2g. Okay, that was... Okay, that one I think we did in class. You just have to rewrite that one as a summation. So that is... Let me erase here. So 2g, you've got that 1 plus 1 over 2 cubed root of 2 and 3 cubed root of 3 and so on. So that's 1 over n times n to the 1/3, or 1 over n to the 4/3, right? For each term. And that's a sum now from n equals 0 to infinity. So that's a p-series. P is 4/3, greater than 1, converges. Ah, darn it. Second time I've sat on an eraser the past 2 days. Can we do 3b? What is 3b? Oh, of course you'd want to do 3b, wouldn't you? Let's see. That one... trying to think if ratio or the root test might be better for that one. Let's see. Let's try the ratio and see how it goes. Because if we can avoid doing the natural log stuff, that's best, right? Seems like you're really worried about this interval of convergence stuff. Alright. So we've got some, there's a -1 to the n times 3 to the n times, what is it, x to the n? Yeah. So right off the bat, I think I'm just going to put these two together. If they're both at a power n, why not? So we need limit, n approaches infinity, absolute value, every one of these things to the n plus 1. All over the original. Normally multiply by the reciprocal, but because this is no fraction, it's just, might as well write it the original way. All less than 1. These -1s here are going to go away when we take the absolute value. The 3x to the n's can cancel. They have to stay inside the absolute. So actually this goes all together. So we have absolute of 3x. We still got limit, n approaches infinity. Don't need the absolutes anymore. N plus 1 over n left behind, all less than 1. Right, again, these disappear with the absolute. Divide everything here by n. pretty easily goes to 1. We have absolute of 3x less than 1. That means it must fall between negative 1 and 1. So negative 1 less than 3x less than 1. Divide it all by 3. That's your interval. You just got to test the endpoints. So left endpoint, let's see, I think it was 1 to infinity. Yeah. So negative 1 to the n, n times, and we're plugging in negative 1/3 for x. So 3 times negative 1/3 becomes negative 1 to the n. So this all just becomes sum of n, because negative 1 to the n times negative 1 to the n becomes 1. Sum of n, I can tell you right now it's going to diverge, but we can turn it into a p-series. It's 1 over n to the minus 1. P-series, p equals negative 1. It's less than 1. Diverges. That means we do not include that endpoint. Then we do the right endpoint. So again, plug in. This time we're plugging in 1/3 into the original. So 3 times 1/3 is going to give us 1 to the n, and 1 to the n is just 1. So you just get this left behind. And that's an alternating series, so you need to prove that it's decreasing. Well, absolute value of this gives us n, and n as n gets larger is increasing, so fails. Right, alternating series test. Oops, test, because it's increasing. Oh, my handwriting's terrible. And so this also diverges. So, oops, we're not including either. It's negative 1/3 to 1/3. I do that too quickly. Dang it. Gotta love allergies. Okay. Any other problems you guys would like to see? Eight A. All right, what is 8? Use the given power series to evaluate each limit. All right, so arctan minus x over x cubed. So we just got to write out the first couple terms of arctan and then plug them in to the limit. Room over here. All right. let's write out the first couple terms of arctan. So it's -1 to the n x to the 2n plus 1 over 2n plus 1, and it's a sum starting at 0. So plug in 0. -1 to the 0 is 1. This is x, and over 1, so just x. Plug in 1, you get a negative term. This becomes cubed over 3. Plug in n equal 2, -1 squared is positive. That becomes to the 5th power over 5. Next one's going to be negative, and so on. I don't think we even need that many terms. The limit, the limit we're looking for is limit as x approaches 0 of the arctan minus x over x cubed, right? Okay. So I just need to plug in for arctan of x. Let's plug in the first 3. So this is limit x approaches 0, x minus x cubed over 3 plus x to the 5th over 5, all minus x, all over x cubed. So we can get rid of these x's. If I divide these by x cubed, then I have limit x approaches 0. Is that the right limit, or did I change it up? Make sure I'm doing the right one. I think it is 0. Because typically that's the only ones that help. Yep, okay. Alright, and divide these by x cubed. This is minus 1/3 plus x squared over 5. And if I had any more terms, they would have more x's in them. But x is going to 0, so this goes to 0, and I'm just left with minus 1/3. Yeah, they look bad because of the summations, I guess, but they're really not that bad. Any other problems I can do for you guys? I think we did one of the power series problems because we did the quiz. We did a power series for an integral. We did a power series for a limit. Let's see, hold on. Did we do? Yeah. So that was the quiz was. You got to find. We did not do a Maclaurin series. If you wanted to do one of those, I think I did both of those yesterday though. So that's already up. We've done 2 of the power series interval of convergences, and we've done just a few of the convergence divergence testing. I mean, we still have to do plenty of that for interval of convergence. Was anybody having trouble with 2a? I had some people yesterday that were getting the wrong sum. Yes, I thought I mentioned that the power series is already there on the test, so you don't need to write any of that down. 4b, what's 4b? Sure, I can do 4b for you. So the Maclaurin for cosine of 2x All right. So f of x is cosine of 2x. We would need f prime and many of its derivatives, so double prime, triple prime. Let's go to the fourth. I think that'll be enough. Differentiating cosine, you get a minus. Derivative of the inside is 2. Derivative of cosine is a sine. That's a chain rule there. Now if I differentiate sine, I get cosine, and I get another 2 outside. Again, derivative of cosine is minus the sine, so we get positive now, and we get another 2 outside. And again, another 2 out there, and we're back to cosine. So I did that many terms because typically I ask for 3 non-zero, and for the Maclaurin you plug in 0 for x. So if we did that, right, f of 0, prime, double prime, and so on. Then when plugging in 0, cosine becomes 1, sine becomes 0. So these two are 0. The cosines are 1, and you just get the coefficients. So 1, 4, or negative 4, and positive 16. Looks like we're... Oh my goodness. Bunch of random stuff here. Great. Yeah, I see that. So now I can't see what you guys actually are writing. My goodness. Frank, why did you write that? Can I refresh it? Alright, I'll just leave it alone for now and finish up the problem. Sorry about that, guys. That was crazy. Alright, so I took the derivatives. I've now plugged in 0 everywhere. These are my terms for my Maclaurin, or at least the derivatives. So I now need to start plugging in to the Maclaurin. Remember that the first term is just f of 0. The next term would be f prime times x to the first over 1 factorial, and maybe we can write this over 0 factorial and times x to the 0 if that helps you. The next term is minus 4 times x squared over 2 factorial plus 0 x cubed over 3 factorial, and finally plus 16 x to the 4th over 4 factorial. So it's very important that you include the 0 terms when writing this out and then get rid of them. Otherwise, my guess is you would probably write 4 times x and 16 times x squared, which is incorrect. So once you've written them all out, then you can say, okay, that's 0, and I'm left with 1 minus, let's see, 4 over 2 factorial, that's going to be 2x squared, and then 16 over 4 factorial. Let's see, do I want to do that, or do I want to, let's see, it'll be 2, and that's going to be a fraction. So let's leave them alone and see if it works. This is 4 over 2 factorial, and then plus 16x to the 4th over 4 factorial. Okay, so 4 is 2 squared, and 16 is 2 to the 4th. And we could write 1 as technically 2 to the 0, x to the 0 over 0 factorial if you wanted. So that's where we get the pattern from. So this would be the summation n equals 0 to infinity. It looks like 2x to the 2n, right, because it has to be even, divided by 2n factorial, and then it alternates sign, so times -1 to the n. And if you look at that power series and compare it to the one that you get for cosine of 2x, or cosine of x, right, cosine x is equal to the sum of -1 to the n, x to the 2n over 2n factorial. So it looks exactly like the cosine one, except instead of x, there's 2x plugged in. Right, so you should, if you know this guy, you should be able to get to this one just by saying, oh look, well there's a 2x, well I would just replace that by 2x. But the whole point of this exercise is to build the summation, right? That's a good check to go that way. So any questions about that problem, guys? Okay. Any other problems you would like me to do? Oh, I did see, I think, before all that nonsense in the chat, somebody had asked, how do you find the sum? So yeah, and someone wrote it down. It was geometric. You break it into 2 parts. But the part that was important was you had to make sure that the sum, where the sum starts. So if the sum starts at 0, or if it starts at 1, the sum is different. If it starts at 0, the sum is a over 1 minus r. If it starts at 1, then the sum is ar over 1 minus r. And I think that's where a lot of people were getting confused. What is 8a? I did 8a earlier. All right, well, it's recorded if you want to look at 8a. We started at 9:30. All right, any other questions, guys? I am perfectly fine with calling it a day if you guys want to end a little early. And then if you have other questions, you're welcome to email me or set up a video chat or something. And let me tell you that the test is going to be the same format as before. All right, I'll put it up on Blackboard at class time. And I'll give you 3 hours. If you do not turn the test into me in a PDF format, then I will not be able to mark it up. Yeah, well, I had suggested doing that, so yes, absolutely. Frank, you say you don't see the recording from yesterday, so let me check. So I'm pretty sure I put that up there. Maybe it didn't upload. Let's check. Let me go ahead and pause recording while I'm doing that.